So there we go. There's our diagram. We need to fill in some information now. So it says it rejects all ball bearings larger than 2.4. Okay, so obviously if they're larger than 2.4, I'm hoping you're sensible thinking that that's there. Yeah? And this is the bit larger than it. And it rejects under 1.8. So that's that.
Wait,
Mine looks...
the other way around. And 1.8 be in the...
Oh, so in the unshaded is what we keep. Okay, so it's rejecting the more than...
Does it matter?
Pardon?
It doesn't matter which way they are. Because it says larger than 2.4, so wouldn't that be the smaller? We don't...
No, because if it's larger than 2.4, well, there's 8% are rejected. Oh no, hang it. 5.5% are rejected for being too big.
Rejected.
Yes. Sorry. Yeah? Because the probabilities they've told us about are the bits that are rejected, so that's why I've shaded those sides. Sorry, I should have made that clear. So 5.5% are too big, so then this decimal here is what?
0.55.
0.055.
0.55.
Okay, Joshua fell into the trap.
High five.
I was trying to ignore her, and she kept saying it louder and louder.
0.08.
Thank you, Olivia.
How are we getting any of these numbers?
From the question, sweetheart. So it says it's found 8% of the ball bearings are rejected as too small. So the probability that they're less than 1.8 are too small. Yeah? And then 5.5 are too big. Okay? But it's really, it's really important, like, do say, if you're sitting there thinking, what the heck is she on about? I don't know where she's going with this, I have no idea what's going on. You have to say something, because later on, it might be too late and we've just all gone off. Okay? Alright, so now, same principle as before, we can't use these numbers as they are. Well, sorry, that's a lie. We can't use our calculators to help us because we've got these numbers at the bottom and that's what the calculator tells us. And we can't use our calculators because we don't have the mean or the standard deviation. So we're going to use both of these two separately and find equivalent z-scores for both of these two numbers. All right? So I'm actually going to draw two separate diagrams for this though. So this is my first z, and this is looking at the 1.8. Okay, so we're focusing on this one on the left. You can see, right, Jennifer? All right, so this value here is what we're trying to find. This is the z-score we're trying to find. We know that this shaded part is still 0.08. But now, because we're talking in terms of z, we know that this is 0 and our standard deviation is 1. I'm going to draw the other diagram and then we're going to chuck them both in the cap. So focusing on the z-score for the 2.4 information. Oh, that's a bit of a dodgy one. 0. So z is the standardized normal letter that we use once that we've changed it. You remember I said like we change test scores to be percentages so we can compare them. We're able to use these z-scores to compare data and make them all uniform.
I thought you said beautiful.
Or beautiful. Okay, so this is my z-score, so that's z1, and we're finding this z2. Which bit of information do we stick into the calc? Which, yeah, I know, but well, because I was trying to avoid doing this. Because which bit do we put in the calc? The left. So we're going to put this area in, which is, in this case, what?
0.045. 0.0.
0.6.
0.0945.
It's 0.995.
0.945.
Okay, these questions, I cannot ever see them being on the non-calc. Okay, so if you are not good at doing 1 subtract 0.055 in your head, please put it in the calculator, alright? Don't make a silly mistake by it. You could have perhaps thought back into the percentages, so 100 take away 5.5 might have been easier, 94.5, and then you could have changed that. Alright, so either way, that's how we would do it. So now we're going to try and find our 2 Z scores.
You don't leave it up weird with all what's in it.
Okay, so let's chuck all this in the calc. So second dish, so we're trying to find Z, because it's how the calcs work. It's just,
What's one of the things?
so we're going to do this first, this top one, we're finding Z1.
So what do we do? Oh, inverse.
So we're trying to find here, and what was my area here? 0.08.
0.08.
Now, hang on a minute. Before we do this, let's check you've been paying attention.
Are we getting inverse?
Yeah, we're doing inverse because we've got the area. What kind of value is Z1 going to be?
Negative.
Oh, I'm loving your work, Cameron.
I said it in my head.
I said it before she said it.
Oh my God. You lot, you lot are so competitive. All right, negative 1.41.
What? Zero? Is that the Z?
I got negative 1.
Yeah, but you brought
That's your Z score.
you brought 368.
We
probably
We
did
did
the
the first one first, even better.
Here, this is the top one. The top one, Z1.
This voice recording is going to be funny.
You have your-
What? Swanee, did you do, what's wrong?
She got 0.1.
Oh, instead of 0 and 1?
What do we
You
put
put
in the
0.1
area?
as your standard deviation instead of
Okay, now we're going to do the other one. Oh, shush now. Shushnas.
ahead of the game.
Wait.
Just-
0.945.
Yep, totes.
Is it because it's the left?
Yes, absolutely, Jennifer. You are rocking it.
What did you say, Jen?
I said it's 0.
1.60.
That's good. Because it's to the left, that's why we put it in the calculator.